Hello everyone. We continue lecture 6 about the probability distributions. Today we will learn binomial distribution. Now we will show you the conditions when we can apply binomial distribution. First we have n observations, a fixed number of observations. We do same thing n times. We call them trials separately, okay? We do the same trial n times, same experiment. For example, we can toss a coin 15 times, 15, n equal to 15 in this case. We can check 10 light bulbs taken from a warehouse that they are defective or not. Okay, n equal to 10 for this case. In each observation or in each trial, you have just two possibilities for each trial. For example, when you toss a coin, you can have just map side or direct side. For the light bulbs, you have just two possibilities. It's defective or not defective. And we call these two possibilities generally success and failure. It's depend on which you select the success for your question, okay? And the probability success we sign by pi, and the probability of a failure is 1 minus pi. For example, when we toss a coin, probability obtaining their map side is 1 over 2 for each trial here, for each observation here. If, for example, probability that light bulb being not defective is 0.90, this should be same, must be same for all these 10 light bulbs, okay? Only for this case you can apply binomial distribution. Yes, constant probability for each observation. Probability of map side is the same each time we toss a coin. And the final thing is that observations are independent. The outcome of one observation does not affect the outcome of other. You can understand from the exact equation example. For example, if you toss first coin and then second coin, how can first coin affect the probability of the second coin? It's impossible, okay, because they are not related to each other. And for light bulbs, you can say same thing. If the first light bulb is defective, it cannot affect the probability of the second light bulb being defective or not, okay? So you understand that you have these conditions, all of them true, then you may apply binomial distribution. Here is binomial distribution formula. In this formula you have three parameters, x, n, and pi. What we have in this part? This is actually formula for combination nx, okay? And here you have the power of pi, where pi represents the success, and n minus x power of 1 minus pi. This calculate for us, this formula calculate for us probability of x success in n trials, okay? You do same thing n times, okay, repeatedly, and what is the probability that x of them will be successful? Of course, with the constant probability pi, probability of success pi on each trial. Here, x number of success in sample, n sample size, the number of observations, and pi probability of success. Let me show you a simple example. Suppose that we flip a coin 4 times. Automatically n must be equal to 4. The probability of success if we talk about the map side, is 0.5. Of course, probability of failure, the other side, also 0.5. See? And the x, which represent the number of success, number of map site, can be, for this question, 0, 1, 2, 3, or 4. For each case, you may calculate the probability using this formula. When, for example, none of them map site, you should put in the formula x0. What's the probability for these conditions? Map site, number of map site equal to 1. Just x equal to 1, and the n 4 pi 0.5. It's automatically calculate for you probability. Now let's consider example 2 about the calculating a binomial probability. What is the probability of one success in 5 observations if the probability of success is 0.1? Automatically, if they say probability of success is 0.5, it means that for all observations it's 0.1. 5 observations, so n equal to 5 automatically. Probability of success is 0.1, pi equal to 0.1, and 1 success, so x equal to 1. Now our work, just plug it into our formula and we calculate the answer this. Of course, the formula of binomial distribution a little bit hard. You need to calculate here powers of some decimal numbers and then combination formula. So there is also table for binomial distribution by using which you can easily calculate simple probabilities about binomial distribution. Let's go and look at it. Here is binomial distribution formula. Look at this table. Here, in this part, we show the probability of success. It starts from 0.01 and ends up with 0.15. The values of n, here we have, this is the part of the table, that's why n starts with 2, 3, 4, 5, 6. Okay, and for each number n, we have x values. X 0, 1, 2. X represents the number of success. When number of trials 2, number of success can be only 0, 1, and 2. If number of trials 3, success can be 0, 1, 2, 3. Okay, number of success cannot be more than the number of trials. What can be 0? None of them success. Okay, let's consider just this case. When the number of trials 6, in this case, number of success can be from 0 to 6. Okay, here is the directions which we use if probability located here. If the probability of success located here start from 0.01 till 0.50, you will use this direction, and n and x you will take from here, from this direction. Okay, but it's possible that sometimes probability of success more than 0.50 or 0.5. In this case, you will take the probability of success from here, and values of n and x from here. Look at, when n equal to 2 and probability of success 0.55, the values of x, the number of success, can be 0, 1, 2. When n equal to 3, x can be 0, 1, 2, 3. When n equal to 6, probability of success can be 0, 1, 2, 3, 4, 5, and 6. Okay, now let's solve the previous question using this table. What was there? Number of trials 5, number of success 1, probability of success 0.10, and in the intersection of it we obtain this number. It's the 4 decimal place, accurate with 4 decimal place of the probability of this situation. And try to also follow this rule to write the probability. First, you should write x, and then n, and then pi. Okay, x1, n5, pi 0.1, and the probability of this is 0.3280. If you want, you can go back and look to the formula. We have the same thing with 4 decimal accurate. Okay, 3281, and here 3280. Okay, I know there is a little bit, but don't worry, just 4 digits completely enough for us. More example. Suppose that we have n equal to 10, number of trials 10, number of success 3, probability of success in each trial 0.35. What is the probability of this situation? Automatically you must do here, you must apply here binomial distribution. Here is the part of table. You see, for because the probability here less than 0.5, we should use this direction. On the first row we select 0.35, it's here, and 10 of course, 0.35, it's here. x3, number of success 3, you select this and draw some horizontal line, and then you see here intersection equal to 0.2522. This is your probability. If n10, x8, pi 0.45, again the same part of a table, 0.45 you select from here, x8 you select from here 8, and in the intersection you see this number which calculate for us the probability. Example again. Suppose that we want to calculate this probability. As you see here, pi equal to 0.04, so you will use this direction, 0.04 here. X n3, so n3, x2 here. You select this point and draw the line, and here with this intersection. Look at 0.0046 for this. One more example. x2 n4, pi 0.07, n4, again something which is less than 0.5, you use this direction, 0.07 here, n4, x2 here, intersection here, okay, 0.0254. You can calculate this also by using the formula of binomial distribution. You will obtain the same result. Next example. Here, as you see, pi equal to 0.55. If pi is more than 0.5, you should use this direction. Okay, 0.55 we have here, n6 we have here, x1 we have here. What is the intersection? This thing. Okay, 0.0609. Pi 0.70. Again this direction here, n5, and x of course 3, intersection here, 0.3087. Okay, next question. Given that x2 n4, pi 0.60, because pi 0.60 we use this direction for pi, and for n and x we use this direction. Let's select first 0.60 here, n4 here, and x value 2 here. So intersection is this number. That's the answer. Next, pi 0.65, n3, x1. again this direction because pi more than 0.15. Yes, and 3x1, correct. Next here pi is 0.03, so we use this direction, 0.03 here, and 6 and x3 and 6x3. Okay, answer this number. Next one, x2 and 4, pi 0.01, see, 0.01 and 4 x2. Answer is 0.006. Now let's consider the questions about the inequalities. Suppose that we want to calculate for pi 0.65, that is success in each trial. If it's 0.65, if you have n trials, what is the probability that success, the number of success will be less than 3? Yes, this is a table where we have 10 also. This is a part of table. Because of 0.65, we use this and these directions. Select 0.65 and end 10. X less than 3, it means that the value of x can be 0, 1, and 2. So you should add these three numbers, 0, 1, 2. If you add them, it will equal to 0.0048. If you have this thing, x more than 1 and 9, pi 0.01. 0.01 here, and 9, yes, and x more than 1. You should add all this part, you see, more than 1, it means 2, 3, 4, 5, 6, 9 also, all of them. These lines represent 0, okay, don't worry about them. These are same thing with 0, they are very close to 0, that's why we show it them as a line. If you add up these 7 numbers, 8 numbers, you will obtain there 0.0035. Next question, pi 0.90 here, and 8 here, and x 0, 1, 2, 3, 4. See, draw two lines here for 0 and here for 4. If you add up these numbers, you will obtain this. Pi 0.06 and 7, x more than or equal to 3, 0.06 here, and 7 here, x more than 3, it's 3, we start adding starting from 4. Yes, this part, start adding, no, starting add from 3, because 3 also included this, and these numbers. The answer here 0.0063. Now let's consider the case with double inequalities. This is the table where we have the number 20, number of trials 20. Suppose that this question, x between 2 and 13, both of them included, and 20, and x 0.01. You see, we should start adding from 2 till 13, this part, you see, from 2 to 13. Add up all these probabilities, and if you add up them, answer will be 0.0169. Here 4 not included, but 7 included. 0.60, we use this direction, starting from 5, see, 5, yes, this is a lower bound, and the upper bound is 7, see, 7. This, three numbers, if we add up them, we will obtain this. Next question, 4, 9, none of them included, so we should start from 5 and end up with 8. For pi 0.10, some students make mistake with 0.01 and 0.10. Okay, 0.10 is this number, not this, 0.10 here. Between included 5 and 8. 5, you see, and 8, you see. Okay, if you add up these numbers, you will obtain this. And the last one, 12, included, 16 not included. We should start from 12, go to till 15, 15 also included, 0.91 here, start from 12, 12 here, and end up with 15. If you add up them, you will obtain this answer. That's all about double inequalities for the binomial distribution. Now let's consider the characteristic of binomial distribution by graph. The shape of binomial distribution depends on the values pi and n. If n5 for x0, 1, 2, 3, 4, 5, if you calculate these probabilities, you will obtain this graph. Yes, if n5 but pi 0.5, your graph look like a symmetrical. Okay. Here, other characteristic of binomial distribution, the mean and variance. Mean for the binomial distribution equal to n multiplied to pi, and the variance equal to n number of trials multiplied to probability of success multiplied to probability of failure will give us variance. And standard deviation, of course, the square root of it. Yes. Now let's consider some examples about how to calculate the mean and standard deviation for binomial distribution. If our n is 5, pi 0.1, then mean equal to this by this, 0.5. Standard deviation, this number, for average being 2.5, for the n5 and pi 0.5, the mean equal to 2.5 and standard deviation 1.118. Okay. What does it mean? Mean, it means that the average value of x here 0.5. You see, we have many values for x. It can be 0, 1, 2, 3, 4, and 5. But the average of them, including their probabilities, equal to 0.5. Because most of the numbers here, we have just few numbers here. So the average 0.5. Okay. Here average 2.5. Why this happening? Because as you see by the graph, from the graph, they're symmetrically distributed. We have the most of the numbers concentrated in the center of the distribution. Very few numbers we have here and here. So average equal to 2.5 as you see here. Okay, let's consider this example. A student is taking a multiple choice exam in which each question has 4 choices, 4 answers. Okay, assuming that she has no knowledge of the correct answer to any of the questions, she has decided on a strategy in which she will place 4 balls, marked A, B, C, and D. It means that she don't know the answer, just she write the answer directly, selecting one of them without thinking. She randomly selects one ball for each question and replaces the ball in the box. In the marking on the ball will determine her answer to the question. There are 5 multiple choice questions on the exam. What is the probability that she will get 5 questions correct, at least 4 questions correct, no questions correct, no more than 2 questions correct? First, you should understand that why we can apply here binomial distribution. First, you have 5 questions. Yes, this is the number of trials. Okay, first condition, you have n trials, n equal to 5. Second, probability of success in each trial same. Because the student not prepared for the exam, she don't have any idea about what answer is correct. So therefore, probability of selecting correct answer for her is 1 over 4, 0.25. Okay, and this probability 0.25 not changed from trial to trial. It's the same for all 5 questions. Okay, This is another condition. And then something about x. 5 questions correct, it means x exactly equal to 5. At least 4 questions correct. X more than or equal to 4. No questions correct. X equal to 0. No more than 2. X less than or equal to 2. Less than or equal to 2. This is for 2 questions correct. Okay, now let's consider solution. For solution, we may apply the formula for binomial distribution, or you may use table for binomial distribution, up to you. There is also third way for solving questions about binomial distribution. It's a LibreOffice calculator. You may write a function. We will talk about after finishing all discrete probability distributions. Right now, for this question, we select a table method. Pi equal to 1 over 4, which represents the probability of correct answer. N equal to 5, so we can select N5 here, and probability 0.25, which is located here. Okay. For the first, x5, intersection N5, x5. Here, this is your first answer. Second, more than 4. It means we must add these two answers. Yes, these two, 0.0056, no, 0.0156, yes. Third one was probability of x equal to 0. 0 is here, yes, 0.2373. And the last one, x less than or equal to 2. These 3 probabilities we should add, and the answer for this case 0.8965. If you want, you may calculate the average and standard deviation for this distribution just by using their formulas. N pi is this, N pi 1 minus pi this. Okay, that's all. Now let's try to explain these answers. You have 5 questions in exam. You don't have any knowledge about the answer. You just select the answer. So the probability of success 0.25. You see, the probability of writing correct answer for all 5 questions is very, very, very small number. Just 1 over 1000. Okay, 1 over 1000. Very small number. Probability of writing correct answer for 4 question or 5 question is this number. It's 1% probability, approximately 2%. None of the questions correct. The probability of it is approximately 24%, and at most 2 questions correct. The probability of this situation is 90% approximately. That's all. We finished the topic about the subtopic about the binomial distribution, and we understand how to apply it and in which conditions. That's all.